Hello, welcome back to the channel. So let's do one more question on volume calculation using definite integrals. And in this video, we'll do a fairly simple problem, but this problem will use many important concepts of volume calculation using definite integrals. So let's move on to the question and see what the question is about. So the question is about calculating the volume of a tetrahedron. I'm sure most of you would have heard about this term in your chemistry courses, but we'll go over in detail about what are the mathematical properties of this figure. So a tetrahedron is a three-dimensional shape with four faces. You can also consider it as a four-sided dice. So it's like a three-dimensional triangular object, and each of which is an equilateral triangle. So if you have this tetrahedron over here, each of the sides is an equilateral triangle over here. So this is an equilateral triangle, this is an equilateral triangle, and the base is also an equilateral triangle of the same properties with the same side lengths. So now, using the methods of volume calculation using definite integrals, we have to calculate the volume of a tetrahedron with side length L, and we may assume without proof that the height of a tetrahedron with side length L is root 2 by 3 times L. So if you have a tetrahedron which has a side length L, you can assume without proof that the height of that tetrahedron would be root 2 by 3 times L. So now we know that in order to solve this question, we have to take areal strips, and based on the areal strip calculations, we will calculate the total volume of the tetrahedron in this case. And in this case, based on the knowledge of our previous videos as well, we can clearly notice in this case that since this is an equilateral triangle, it's better to take equilateral triangles, because we know that the tetrahedron is a three-dimensional shape, each of which is an equilateral triangle. So we know that if we start building our tetrahedron with equilateral triangles of varying sizes, we will eventually build the whole tetrahedron in this case, right? So it's easier for us to calculate the volume of this tetrahedron using equilateral areal strips, equilateral triangular areal strips. And if you'll start building equilateral triangles of decreasing sizes on top of each other, you'll eventually build the tetrahedron in this case, right? So that is what we had to figure out in order to solve this question. And since in this case we are taking equilateral triangle areal strips, we know that we'll have to calculate the area of our equilateral triangular strip and then integrate it over the whole height of the tetrahedron in this case. So we'll start from y equals 0 and we'll build those equilateral triangles all the way up to the height of the tetrahedron in this case. So this was an important observation that you had to consider while solving this question, and if you are able to notice this observation, the rest calculation is pretty simple. So now since we know that our tetrahedron is formed using equilateral triangles of decreasing sizes, we can take an arbitrary areal strip, an arbitrary equilateral triangle areal strip, and calculate its area based on the given information in the question. And if we are able to calculate this area over here, the area of an arbitrary equilateral triangle, will start building those equilateral triangles from the base all the way to the top of the tetrahedron, right? So if we have this area, we'll integrate this area over the intervals from the base all the way to the height of the tetrahedron in this case. I hope that makes sense. Feel free to comment down if you have any questions regarding this portion. So now the main task is to calculate the area of this equilateral triangle over here. So now for the sake of simplicity, let's invert this tetrahedron and calculate the area of this arbitrary areal strip. And the way to do that is we'll use this given information in the question, that the height of a tetrahedron with side length L is root 2 by 3 times L. And therefore, in order to calculate the area of our equilateral triangle, or the area of our arbitrary areal strip, which would be the same as the side lengths of these cases, and if we are able to calculate the side length of a tetrahedron, we would be able to easily calculate the area of this equilateral triangle over here, which we can easily calculate using the concept which is given over here. The height of a tetrahedron with side length L is root 2 by 3 times L. So we know that the height of a tetrahedron with side length L is root 2 over 3 times L, and we can easily invert this concept, right? Now, in order to calculate the side length of a tetrahedron, if I want to calculate the side length of a tetrahedron where my height of the tetrahedron is given, I can shift this root 2 by 3 over to the other side, right? So this would become my length of the side length of the tetrahedron would become root 3 by 2 times the height of the tetrahedron, right? So now we know that if this is the height of a tetrahedron, and if we have to calculate the side length of a tetrahedron, we'll use this formula over here. So now, for the sake of simplicity, let's invert this tetrahedron and represent it on the x and the y axis so that it's easier to represent the equilateral triangle, and it's easier to also calculate the area of our equilateral triangular aerial strip in this case. So now let's assume any arbitrary height which is denoted by the value y, and we can use this formula. Since we know that the height of a tetrahedron is y, we can calculate the side length of the tetrahedron, and if we know the side length, we can calculate the area of our equilateral triangle in this case, right? But before calculating everything that we discussed, you would also be thinking, why did we invert this tetrahedron in order to calculate the area of our triangular strip? Why did we not simply take this tetrahedron on the x and the y axis, right? You would also be thinking about this concept. So now you'll notice that I can copy this image down and let's invert this image. So now if you invert this image, this would be your tetrahedron formed, right? Ignore the other values which are represented on the x or the y axis, but this would be the tetrahedron formed, right? So now since you're taking your tetrahedron like this would be your x-axis, right? This would be your x-axis, and this is again your y-axis in this case, right? And now if you take this as your arbitrary height, your arbitrary y value, let's consider this is our y value. If you take this y value, you only know that the height, if you have the height of a tetrahedron being given, the length of the side length of the tetrahedron is root 3 by 2 times the height, right? And in this case, this is your tetrahedron, right? Because you want the full tetrahedron to be there, and based on that height, you will get the side length in this case. And now in this case, you'll see that if we take this complete thing as the total height, in order to calculate this side length over here, we'll have to take this height in this case, right? Because this is the tetrahedron which we are considering. We're not considering this portion over here, right? And since we are considering only this portion of the tetrahedron, we'll have to take this height, and in this case, the height would be, over here, this case, the height would be small h minus your y value, right? And that is why if you'll take your tetrahedron like this, with your base on the origin, you'll notice that your height calculations will become more complex. You can still solve this question using this and integrating from this point to this point, but you'll notice that your calculations will become much more complex in this case, because then if you have this height, you'll calculate the side length based on this height, and then you'll use the area of the equilateral triangle. So those calculations will become more and more complex. So that is why we inverted our tetrahedron first and then calculated the area of our triangular strip in this case. Again, you can still take the tetrahedron like this and start solving for the area of your equilateral triangle, but you'll have to notice this concept in order to calculate the area of your equilateral triangle, because if you'll not take this height, you might get all your calculations wrong in this case. So now we know that we considered the height of our tetrahedron the arbitrary height of a tetrahedron formed to be y, because we have to calculate this side length in order to calculate the area of this equilateral triangle. So in order to do that, we know that our height is equal to y. So with respect to our height, we know that we have a formula. If our height is given, the side length of a tetrahedron is this, which would be, so if we have to calculate the side length of a tetrahedron where y is the height of the tetrahedron formed, it would be root 3 by 2 times height in this case, and the height is y, right? So now we have the side length of our equilateral triangle. In order to calculate the area of our equilateral triangle, we know the concept of the areas of equilateral triangles, which we already discussed in the previous math courses. The area of an equilateral triangle is given by root 3 by 4 times the side length square. And now, since in this case the length of our equilateral triangle is root 3 by 2 times y, so the area would be root 3 by 4 times root 3 by 2 y to the whole square. Simplifying it down, it would be root 3 by 4 times 3 by 2 y square. So the area of the aerial strip, your required equilateral triangular aerial strip, it would be 3 root 3 by 8 times y square. So now you have the area, and you know that if you have the area of your aerial strip, in order to calculate the volume of the region formed by your aerial strips, you will have to either calculate integral a dx or integral a dy, depending on which variable you have for the area representation of your aerial strip. So now in this case, since we have a variable y, we'll take integral a dy, and now if you calculate the volume based on integral a dy, you know your area. So your area is 3 root 3 by 8 times y square with dy. The only thing which is left in order to calculate the volume is your endpoints, which is from y equals something to y equals something. And now in this case you already know about the endpoints, right? Since we are building our equilateral triangles from the base all the way to the height of the tetrahedron, we know that the lower y value, the lower endpoint is y equals 0, and the upper endpoint, the upper y value, is the height of our complete tetrahedron. The height of a tetrahedron with the side length L in this case, right? And since we already knew by the formula, we were already given in the question that the height of a tetrahedron when you have a side length L is root 2 by 3 times L. So now you know that your upper y value will be root 2 by 3 times L in this case. So now you know that your lower y value is y equals 0, your upper y value is root 2 by 3 times L in this case. And now this is your final definite integral, and if you'll solve this definite integral, you will be able to calculate the volume of your tetrahedron formed in this question. So that's it for this video. I know this was also a trickier problem, but if you somehow figured out how to calculate the area of your aerial strips, the rest process is just to identify the endpoints, and based on the endpoints, you'll calculate the volume by integrating your aerial strip from the lower endpoint to the upper endpoint, which we already did in this video as well. So in these type of questions, again, you have to identify your aerial strips, your most favorable aerial strips that you can take in order to solve for the volume. And once you have figured out what aerial strips you'll take in order to calculate the volume, you just have to calculate the area of an arbitrary aerial strip and then integrate over the endpoints in order to solve for the volume. So feel free to comment down on this video if you still have any more questions regarding this question or even any more doubts related to this concept. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.